Yes. Yes, you may. Now, so let's do this. All right, so we know that the pH of this is going to be, the POH is going to be equal to 14 minus that, which would be 9.4. Is that right? 9.4. Now, just a side note, please. A side note, good luck on the French test. Last time I spoke French, they had to take me to the hospital. My throat closed up. Okay? So make sure you use 2 decimal places for this. This one is going to be, let's see, 14 minus 9 is 5, right? And then another 0.3, so 4.70, right? That equals the POH. All right, so far so good. Let me erase these equations. Is that okay? Somebody said, is that a constant, that 14, this equation? And the answer is yes, that's constant. And you know where that comes from? That comes from this. That comes from this. And I'll touch on this again in the next problem, where this is actually kind of like an equilibrium, where that number could go up. If that number increases, that number has to decrease in order for that to be constant. Clear? So if I took the negative log of that number, it's going to be 14. So neutral water would be 1 times 10 to the negative 7th. The negative log would be 7. The negative log would be 7. Clear? Okay. So, all right. I have to ignore that. Okay, now, it's a little unnerving having that ring. Okay, so now, if I'm going to take this, I'm going to say 10 to the negative 9.40, 10 to the negative 4.70. Clear? All right, so that's going to be equal to what?
3.98 times 10 minus 10.
3.98
Times 10 to the power of negative 10.
times 10 to the 10. Is that correct?
Yes.
Okay, now, what are the unit labels for that? No, the unit labels are molar, right? But how do we represent molarity when we're doing this kind of acid-base chemistry? What do we do, Neve? That's right, we use brackets. Well done, Neve. We use brackets. We use brackets, and those brackets mean molarity. So 10 to the negative 4.7 is going to be
1.99 times 10 minus 5.
1.99, 2.00. Someone is really trying to call me. 2.00. Negative what?
Somebody's getting murdered.
Okay, please don't say that. Okay. Let me answer this phone. I'm now on film answering my phone. I have no idea who that is. Okay. All right, now. So, what's this one here? This is going to be, I want to find the what? I want to find the negative log. The negative log of what? The negative log of the what?
1.8 times 10 to the negative.
Equals what? Equals what?
1.74.
What is it?
1.74.
1.74. And that's going to be the POH, correct? And the pH would be what? So I'd say 14 minus that, and that's going to be what? 12.26. Okay? And then this one is going to be what?
Negative log
Negative log
of 2 brackets
of brackets 7.3 times 10 to the negative 9, right? And that's going to be equal to what? 8.14, and that's going to be the POH. Always mark down what it is. You know what I'm saying? That can be confusing. You got to keep your wits about you. And then the pH would be 5.86. Clear? Are we done? Is that all on the screen here? All right. Excellent or what? Is that excellent? Excellent. Okay. So we're done. Now, just let me say one thing before I stop. You could do this a different way, where both steps are different. You could say, right, I could say negative log of the pH. I could say, I'm sorry, 10 to the negative pH. And that would give me the H plus ion, correct? Concentration, right? Yes or no?
Yes.
And then I could say 1 times 10 to the negative 14. I could say, I find the H ion concentration, and then I could say 1 times 10 to the negative 14 divided by the H ion concentration is the hydroxide ion concentration. Do you get that?
Yes.
Yes or no? And down here, I could say this value, 1 times 10 to the negative 14 divided by that value, right, is going to be the H ion concentration. And then I could take the negative log of that, and that would be directly the pH. Clear?
Yes.
We're off. Okay.